slow. So in this video, we are going to do the second problem of arrays topic in data structures and algorithm. So today's problem is this two-sum problem. Two-sum two problem. So in this problem, this problem is same as the first one, which is two-sum. So now let's read the problem and see what we have to do in this problem. So given an one indexed array of integer numbers. So this means this line basically means that the in default arrays the index starts with 0, like the first index is 0, 1, 2 and so on. But in this array the indexing starts with 1, which means the first index is 1, second is 2 and so on. So this is the important point. So given an one indexed array of integers numbers that is already sorted, and the array is sorted in non-decreasing order, find two numbers such that they add up to specific target numbers. Let these two numbers be like this, returning the indices of two numbers and added by one as an integer. Okay, so this problem basically is same as the two-sum problem, but in this problem we have two major changes. First is our array is one index, which means indexing starts with 1 2 instead of 0, and the array in this problem, the array is sorted in non-decreasing order. So these are the two important points that we have to keep in our mind before solving the problem. So the first approach could be of obviously the brute force approach, which is not so optimal, so we will not do that in this video. So now second approach could be as same as this two-sum problem, in which we have created our dictionary, and then we have enumerated the array and stored all the values and indexed in key value pairs, and then we searched that our target is in the dictionary or not. So let's do this as same as the two-sum problem. So we will create an empty dictionary first, and after that we will enumerate our array I comma j in enumerate numbers. Now we will store our store these key value pairs, and after that we will start another loop for I in range of length of numbers, and then we will first calculate the complement, which means we will calculate what will be equal to if we will subtract target from first number. So we will subtract target, the first element of the array, which means numbers of I, and then we will check if C in D and if C in D and C of D, I mean D of C is not equal to, if not is not equal to the index, same index which we are searching for. So then we will return our index which will be D of C plus 1. Why I'm doing this plus 1? Because the indexing of this array starts with 1, which means in default arrays it starts with 0. So obviously the whichever index we are getting here will be plus 1. So the second index will be I plus 1, and after that if we will not find our elements which will be equal to target, then we will return the empty array. So now let's run this code and see if it is working or not. So it is showing some errors here. Output is 2, 1 and expected is 1, 2. So okay, so we have changed the indexing position here. So let's do this instead of D of C. So first we will return the index of I, first element, and then the index of second element. Now let's run this again. Okay, so our all the test cases are working. Now let's submit the code and see if it is working with every test case or not. So yeah, it is working with every test case, and it is giving 100% accuracy, which is not of our use. So now we have to find more optimal solution of this problem, because we have given that the array is sorted, and in this solution we haven't used the sorted array. So if we have given that the array is sorted, so we have to use that sorted array for our benefit. So now let's see how you can use that sorted array for your benefit and make this solution more optimal. So if you will think that let me give you an example. Copy this from here and paste it here. Okay. So if you will see here, this array is sorted. Now, if if we will start two pointers, one from here and one from here, which means this will be our left pointer and this will be our right pointer. Now, the target value which we are searching for is 9. Now, if you will add this and this, what value will you get? So if we will add this and this, so we will get 17, which is greater than the target value. So now we will shift this element here. Now we will remove this element and we will search only in these three elements. So now we will move our right pointer here. So the next step is calculate the sum again. So we will add this with this. So by adding this with this, we will get 13, which is still greater than 9. Which is still greater than 9. So we will again shift this to right, and then we will add these two, and this will be equal to 9. So we will get our target value. My writing is very pure, sorry. So we will get the target value 9. Now, if so, the approach is we have to take two pointers left and right, like in binary search, and then we will calculate if the sum of these two elements is greater than target. If the sum is greater than target, then we will shift right pointer to left, and if the sum is smaller than target, then we will shift our left pointer, and if it is equal, then we will return the values. So now let's do this here. So we have to start two pointers. So the left will be 0 and the right pointer will point at the last element of the array, which is length of numbers -1. Why -1? Because the indexing of this array is not the default indexing, it is a one indexed array. So we will -1 to get the last element position. Now we will start a loop. In such a way. So what is the breaking condition of the loop? If left and right cross each other, then we will break the loop. It is same as binary search. So while left is smaller than right, if left is smaller than right, then we will compute this. We will calculate the sum every time. So let's calculate the sum. So the sum will be let's call it S. So the sum will be numbers of L plus numbers of R. So then we will compare if S is greater than smaller than the target value. If S is less than target value, then we will shift our left pointer to right side, which means we will shift our left pointer here. So left will be plus equal to 1, which means left will be +1. And if which means the next condition is if the sum is greater than target. If the sum is greater than target, then we will shift our right pointer to the left, which means minus equal to 1. And else, if the sum is equal to target, then we will return left and right, which means the index position where we have found the element. Now let's run the code and check if it is working or not. So I think there is some problem in the code. The output is 0, 1 and the expected output is 1, 2. Okay, so we have to add +1 here because the indexing is one index. And now let's check the code again. Okay, so our all test cases are working, and now let's submit the code and see if it is working with every other test case or not. So yeah, it is working with every other test case, and we have found the optimal solution. We have seen three solutions of this problem. The first one was brute force, which is not so optimal, and the second one was as same as the two sum problem, and then the third one, which is this. So I did this solution because in this problem it is given that the array is sorted, and if in any problem if this is given that the array is sorted or in decreasing or increasing order, so you have to use that information for your benefit. So that's it for today's video, guys, and in next video we'll solve another lead code problem, which is best time to buy and sell stocks. So stay tuned for video, guys, and thanks for watching.